Okay, so we've all had that moment, right? That the universal moment of panic. You sit down, you've got your coffee, you're ready to go, you press the power button on your computer and just nothing.
Silence. Just dead air.
Or, and I think this is worse than silence, you get the fan spinning up like a jet engine,
Yeah.
but the screen just stays totally black. Or, the absolute classic, the dreaded blue screen of death.
It's that sinking feeling in your stomach, isn't it?
Yeah.
The machine that's your portal to everything suddenly becomes a very expensive paperweight.
Exactly. And the first thought for most people is, well, it's broken, time to call a pro. Or, drop $1,000 on a new one.
Right.
But today, on this deep dive, we're going to try and flip that script. We've been through a whole stack of material on PC hardware troubleshooting, and our mission is pretty simple. We want to demystify the breakdown.
Right, because troubleshooting isn't magic. It's not just random guessing, even though it can feel that way. It's a logical process. It's about elimination. You just have to learn to listen to what the machine is trying to tell you.
Even if it's telling you by, well, saying nothing at all?
Especially then.
So we're going to break this down into 4 main areas, kind of like anatomy. We've got the brain, that's the BIOS and UEFI.
Okay.
The heart power and booting. Then the memory storage and RAID. And finally, the senses, so video and cooling.
It's a great framework. If you treat the PC like a patient, the symptoms start to make a lot more sense.
And I have to admit, I'm excited about this because I've always been that person just mashing the F keys during startup hoping something happens.
The boot dance.
But I never really knew why I was doing it or what I was even looking at.
Well, by the end of this, you'll know exactly why. And, more importantly, you'll know which key to mash so you don't look like you're playing the piano on your keyboard.
Let's start with the gatekeepers then, the brain. We see these acronyms all the time, BIOS and UEFI. To most people, these are just the scary screens you accidentally get into. What are we actually looking at?
So these are the firmware interfaces. This is software, but it lives on a physical chip right on the motherboard. It's the first thing that wakes up, long before Windows or Linux even thinks about it.
And for a long time, it was all BIOS, right? Basic input-output systems.
That's very long time, yes.
That's the old school blue screen with the blocky gray text.
Yeah.
The one where your mouse doesn't work and you feel like you've hacked into the matrix.
That's the one. It's legacy tech now. It's purely text-based. You navigate with arrow keys and, well, honestly, it has some major limitations that we just outgrew.
Like what?
The biggest one for the user is how it handles hard drives. BIOS uses a partitioning system called MBR, the master boot record.
Okay, MBR. Why does that matter to me if I'm just trying to save my photos?
It's about math, really. MBR uses 32-bit values to count the sectors on your drive. Because of that, it hits a hard wall. It can't count past 2 terabytes.
Wait, really? So if I bought a big 4 terabyte drive for my old computer,
the BIOS literally would not see the other half of it. To the computer, it just doesn't exist. Plus, MBR limits you to only 4 primary partitions. It's like trying to run a modern warehouse with a clipboard from the 80s.
So if BIOS is the clipboard, then UEFI is the iPad.
That's a really good comparison. UEFI stands for Unified Extensible Firmware Interface. It's the modern standard. It supports 64-bit, it boots way faster, and it has a graphical interface. You can actually use your mouse.
And I assume it fixes that 2 terabyte limit.
Completely. UEFI uses GPT, the GID partition table. This lets you have drives that are, zettabytes large, and for all practical purposes, you can have unlimited partitions. It's a whole new world.
Okay, so UEFI is way better. But here's the struggle I always have. You want to change one setting. You turn on the computer and you have, like a split second to hit a key? Is it delete, F2,
Yep, 2.
F12?
It's the boot dance, like we said. You're just spamming keys hoping one of them works. It's usually delete, F2, F10, or escape. But here's the irony. Modern computers with SSDs boot so fast that the window to hit that key can be, 0 milliseconds.
So the computer's just too efficient for its own good.
Pretty much. The USB keyboard might not even turn on until after the window has already passed.
That feels like a design flaw.
It does. But there's a fail-safe method for Windows 10 and 11. You don't need to be a ninja. You can go into Settings, then Update Security, find Recovery, and use Advanced Startup.
Okay.
It reboots the computer right into a menu where you can choose UEFI firmware settings. No key mashing required.
That's so much easier than restarting 5 times.
There's an even quicker trick, too. If you're at the login screen, just hold down the Shift key on your keyboard while you click Restart.
No way.
Yep, does the same thing. Forces that advanced boot menu. Or, If you want to feel like a real hacker, there's a command line trick.
Oh, I'm always up for that.
Open up command prompt and type shutdown, ROFT0. It forces a restart straight into the options menu.
I'm writing that one down.
Mm.
Now, beyond the menus, you mentioned UEFI is a huge security upgrade. This isn't just about looks.
No, not at all. This is critical. It introduces something called secure boot.
Secure boot.
You know,
Sounds self-explanatory, but what's it actually stopping?
think of it like a bouncer at a club. When your PC starts, before Windows loads, there's a risk that a virus, specifically a rootkit, could infect the boot process itself.
And if it loads before your antivirus?
Your antivirus can't see it. It's already running underneath everything. It's invisible.
That is terrifying.
It is. Secure Boot holds a list of digital signatures, like a VIP list. It checks the bootloader, the drivers, and if they aren't signed by a trusted company like Microsoft, Secure Boot just says, nope, you're not on the list, and blocks it.
And what about TPM? That was all over the news with Windows 11.
Right. TPM is the Trusted Platform Module. It's a physical microchip on the motherboard, like a tiny digital vault. It stores your cryptographic keys and passwords separately from your main hard drive.
So that's what powers things like BitLocker drive encryption.
Exactly. The key to unlock your encrypted drive is stored in the TPM. If someone steals your laptop and pulls out the hard drive, they can't read it because they don't have the matching TPM chip with the key. Windows 11 made it a requirement because these firmware attacks are getting so common.
It's amazing how much is happening before you even see the Windows logo. Okay, so let's move from the brain to the heart. Power. The first scenario is the scariest one. The dead PC. You press the button, nothing happens.
Yeah, the brick. This is where you have to suppress the panic and just start with the obvious questions.
Is it plugged in?
Is it plugged in? Is the power strip on? And this is a classic. Is that little rocker switch on the back of the power supply actually flipped to the on line, not the off circle?
I think everyone has made that mistake once. You spend hours building a PC, you press the button, your heart stops, and then you realize.
Oh, absolutely. It's a rite of passage. But if all that is fine, you dig deeper, it could be a bad power cable or the power supply unit. The PSU itself is dead. You can use a PSU tester or just swap in one you know works.
Okay, scenario 2. The zombie PC. You get lights, fans are spinning, but the screen is just black, no beeps.
Lights on, nobody home. This is usually a failure of the power on self-test or post. The computer is trying to wake up, but it can't get past step 1.
And the fix is often reseating components. I've always found this weird. Why does taking the RAM out and putting it back in actually work?
It sounds like voodoo, doesn't it? But it's physics. Your computer heats up and cools down constantly. That tiny expansion and contraction can wiggle a component loose by just a fraction of a millimeter.
Just enough to break the connection.
Just enough. Or a microscopic layer of oxidation builds up on the contacts. When you pull the RAM or graphics card out and click it back in, you scrape that off and get a solid connection again. It fixes a surprising number of dead computers.
If that doesn't work.
The next step is to clear the CMOS. That just resets all your BIOS settings back to the factory default. You can do it by moving a little plastic jumper on the motherboard, or even easier, just pop out that little silver coin cell battery for a minute.
Okay, last power scenario. The PC turns on, the screen comes on, but you get a text message. Fixed disk not detected.
This is a communication breakdown. The brain can't find the memory. First, check the cables. Are the SATA data and power cables plugged in securely to the drive?
If they are.
Check the boot order in the UEFI. I've seen this 100 times. Someone leaves a USB thumb drive plugged in, and the computer tries to boot from that instead of the main Windows drive. It fails, gives you that error, and you just have to go in and tell it to look at the right drive first.
So we've got power. We're booting. Now we're in the operating system, which brings us to storage, or memory. And the most famous symptom, the blue screen of death.
We need to reframe this one. Don't think of it as a disaster. Think of it as a really aggressive notification. It's the computer screaming, I ran into a problem I couldn't solve safely, so I'm stopping before I corrupt your data.
It doesn't feel very helpful when you lose an hour of work.
I know. But look closely at the screen. It gives you a stop code like memory management. And now they even put a QR code on the screen.
You kidding? You can scan your broken computer with your phone.
You can. And it takes you to a support page for that specific error. It saves so much time.
The sources also mention using safe mode. How does that help with a blue screen?
Safe mode loads Windows with just the bare essentials. No fancy drivers, no startup apps. If your computer runs fine in safe mode, you know the hardware's probably okay. The problem is a piece of software or a driver you installed recently. It helps you isolate the variable.
What about when the drive itself is physically dying? Are there warning signs?
Usually, yes. If you have a traditional spinning hard drive in HDD, you should listen to it. If you hear a rhythmic clicking sound, the click of death, or a grinding noise, that's a mechanical failure.
And that means?
That means stop everything you are doing and back up your data right now.
And what about SSDs? They're silent.
They are, but for both types, you might see disk thrashing. The little hard drive activity light is just on constantly, but your computer is frozen or super slow. That means the drive is struggling to read data, retrying over and over.
And the drive itself knows this is happening. Right. There's a system for it.
Yeah, SMART. It's a self-monitoring technology. If your drive is about to fail, you'll often get a smart error when you boot up. That's the drive waving a white flag. Do not ignore it.
Let's get into the big leagues of storage. RAID. Redundant Array of Independent Disks. This sounds like it should be invincible.
It sounds like it, but it isn't. It's resilient. But there are two very different ways a RAID setup can break, and you have to know which is which.
What's the first way?
A single drive failure. One of the disks in the array dies. The system will usually stay running, but it'll warn you that the array is degraded.
And this is the redundant part of RAID. Your data is still safe.
Exactly. Assuming you're using something like RAID 1 or RAID 5. The fix is pretty easy. You just pull out the bad drive, pop in a new one, and the system rebuilds the data onto it automatically.
But then there's the second way it can fail. The controller failure.
This is the nightmare scenario. The drives themselves are fine, but the card or chip that controls them, the RAID controller dies.
And the whole array just disappears.
To the operating system, yes. It's gone. And you can't just plug those drives into another computer to read them.
Why not?
Because the controller speaks a very specific language. It's the only thing that knows how your data was split up and written across all those drives. If the translator dies, no one else knows how to piece the message back together.
So if the controller dies, your data is effectively held hostage.
It is, unless you can find an identical replacement controller. Same model, sometimes even the same firmware version. If you mix and match, you risk corrupting everything.
So note to self, RAID is not a backup.
RAID is not a backup. RAID is for uptime. Backups are for data safety. A crucial distinction.
Okay, let's move to our final system, the senses, video and heat.
And heat is the #1 enemy of electronics, period. If your computer randomly shuts down in the middle of a game or locks up completely,
It's probably overheating.
it's almost certainly thermal protection kicking in. The CPU gets too hot, and to save itself from melting, it just pulls the plug.
And the fix is a can of compressed air.
That's the first step. Dust is an amazing insulator. It's like putting a wool sweater on your CPU. Clean out the dust from your heat sinks and fans. But deeper than that, you have thermal paste.
Right, the gray goo between the chip and the heat sink.
Exactly. After a few years, that paste dries out and turns to chalk. It stops transferring heat. Cleaning that off and reapplying it can drop your temperatures by 10, even 15 degrees.
And you can control the fans in the UEFI, can't you?
You can. You can check the fan profiles. Maybe it's set to silent mode. If you're overheating, just switch it to performance or turbo. It'll get louder, but it'll stay cool.
Okay, last one. Video issues. You turn on the PC, you hear the Windows startup sound, but the monitor just says, no signal.
Don't overthink it at first. Check the input. Is your monitor set to HDMI 1, but your cable is plugged into HDMI 2?
Happens all the time.
All the time. Then check the cable itself. And here's a big one for desktops. Make sure you're plugged into the port on your graphics card, not the one on your motherboard up top.
Ah, because if there's a graphics card, the motherboard port is usually disabled.
Exactly. You plug into the wrong one, you get a black screen, or if it works at all, you get terrible performance because you aren't even using the powerful card you paid for.
That brings us to our last point, sluggishness. The computer works, but it feels like it's wading through mud.
If we've ruled out heat, look at the storage drive again. If your SSD or HDD is almost completely full, performance will just tank. It has no room to work.
And for older mechanical drives?
Fragmentation. The pieces of your files get scattered all over the spinning platter. Running a defrag puts them all back together so the drive doesn't have to hunt for them. But, and this is important, never, ever defrag an SSD.
Why not?
Because SSDs don't have moving parts, so it doesn't matter where the data is. Defragging an SSD does nothing for performance, and it just causes a bunch of unnecessary writes that actually shorten the lifespan of the drive.
That's a great tip. So we've gone from the brain to the heart to memory to the senses. It really is like a medical diagnosis.
It's the best way to approach it. You are a detective. You isolate the variables, hardware or software, cable or monitor, drive or controller. You change one thing at a time until the problem changes.
And it's a lot less scary when you know what you're looking for.
Absolutely. The machine wants to work. You just have to clear the obstacles.
Before we wrap up, I want to leave our listener with one final thought.
Mm.
We talked a lot about these modern security features, secure boot, TPM.
They're essential for modern cybersecurity, yeah.
They are.
Yeah.
But does that safety come at a cost? As these systems get more locked down, harder to boot into alternate operating systems requiring specific digital signatures, are we making computers safer, or are we just making them harder for the average person to repair, to modify, and to truly own?
That is the central tension in tech right now, isn't it?
Mhm.
Security versus flexibility. It's a very fine line to walk. When you lock the door to keep the bad guys out, you sometimes make it a little harder for the homeowner to get back in.
Something to think about. Thanks for listening to The Deep Dive.
Stay curious.
See you next time.